Okay, so today we are doing tree diagrams. It is a pretty straightforward process. It's just a lot to keep track of. There's not a bunch of different formulas that you're going to need to use. It is different than what we did in the last lesson. The one thing that carries over from the last lesson is the idea of conditional probability. So we use tree diagrams when we have a chance process that involves dependent. So this first blank is the word dependent. Or successive events. Dependent or successive events. Successive, you can also think about that as sequential. Like, what's the chances that the first 3 ties are going to be yellow and then the 4th one is blue? Like, that would be sequential. Whenever you see dependent, you should kind of have in the back of your mind that it has to do with conditional probabilities. And because of that, we're going to be working with a specific formula to help us through this. So the first formula is the one that tells you the probability of A and B if your events are conditional. So I will pull it if I can find it. So in our notes from last time, we have this formula. This is the first conditional formula that we got. So I'm going to use that today. I'm going to write this down on my Post-it note so I can move it around where I need it. The probability of A given B is the probability of the intersection over the probability of the given event. So this is from notes from last time. It's conditional probability. Then the other formula that we're going to use is this one. And they're related. They come from each other. You get this formula by rearranging this formula. So I'm also going to write that one down. So I'm going to use the probability of the intersection A and B is the probability that B happens times the probability that A happens given B happened. So these two formulas are related. They're just rearranged. They have all the same pieces. They're just in different positions. So I'm just going to keep this to the side and refer to it when we get to a problem where it applies. I decided to put it on a Post-it note because when we turn this page, I want to be able to refer back to it without having to flip back and forth with my pages. So, the best way to learn about tree diagrams is to just dive right in and do one. So we're going to start with this university professor that fails 20% of his students. So this professor fails 20% of his students. After the final, he polls his students and asks how many of them studied more than 3 hours for the final. So of those that passed, 72% said that they studied more than 3 hours. And of the kids who failed, 31% said that they studied for more than 3 hours. So they have given us 3 different probabilities here. They've given us the probability that a student failed, the probability that he studied, given that he passed, the probability that he studied, given that they failed. So when we make a tree diagram, we start with the event that they gave us the probability for. So they gave us P of F. They told us that the probability a student fails is 20%. So I'm going to say that F, capital F, equals fail or failed. Now, for this example, I'm going to use F complement for past. If you want to use the letter P, then use the letter P. If you think that that's going to help you keep track of your probabilities better, then you should use the letter P instead of F complement. So far, so good? Yes, no? Okay, then the other elements, or the other piece that they have added on for me is the studying. So I'm going to need a letter for that. I'm going to call S, studied more than 3. You might want to write hours just in case you forget. Which means S complement is studied less than or equal to 3. So the information that they gave us was how many students failed, and then given who passed and failed, whether they studied or did not study. So we start with, like I said, the probability that they gave us, which is P of F. They gave us the probability of a student failing is 20%. Notice that they did not give us P of S. They did not give us P of S. They only gave us P of F. I'm going to skip a little bit of space, and then below that, I'm going to write the complement. If 20% of the students failed, that means how many students passed? 80. So this first portion of my tree diagram adds to 100% of the data, or 100% of the students. Now here comes the conditional or dependent or sequential part of this situation. So I'm going to draw 2 legs coming out of my tree, or 2 branches. They told us that the probability that a student studied, given that they failed, is 31%. They told us of those who failed the final, 31% said they studied. So I got this from what I highlighted in purple. They did not give us the probability they studied. They gave us the probability they studied given they failed. Well, the matching event to this, or the other side of this, is the probability that they did not study and failed. Well, if 31% studied and failed, that means that 69% did not study and failed. And that makes sense to me. It makes sense to me that the majority of kids that didn't study are the ones that failed. Of the group of kids that failed, the majority of them did not study. You're hanging in? So they gave us these 2. Now they gave us one additional piece, and it belongs down with the kids who passed. So I sometimes forget because F complement gets me all frazzled. So I'm going to remind myself this means they passed. The probability that somebody studied and passed is 71%. That makes sense to me. Of 72%. Of all the kids that passed, the majority of them studied. This is the other piece that they gave me. Which then means that the other side of that event, or the complement, is that they did not study given they passed. And that's a much smaller percent. What percentage is that? What is it? Huh? 28. So these add to 100. These add to 100. Now when you go about, setting these up on your own, one way that I remember what goes where is the following. If I have P of F here, that means then that the given on both of its branches is F. And what changes is the other event, which is studied. And that follows here. For F complement, the given on both of those branches is F complement. So when we set up these tree diagrams on other problems, this is a really good way to help keep us on track. Okay, now we're going to add in one last element. Well, going back to this formula, I know the intersection of an event if I know the probability of an event and the given probability, or the conditional probability. That's what we have here. So you don't have to write this on your Post-it, but I will. If I want to know the probability that they studied and failed, I need to know the probability that they failed and multiply that by the probability that they studied given they failed. We have these two things. We have P of F right here and P of S given F right here. So we can write a comma next to that conditional probability, and we now know that the probability that we select one student at random, and they studied and failed, is equal to 0.21 times 0.31, which I believe is 0.062. So the probability that you randomly select one of the kids, and they're a kid that studied and failed, is very small. It's 6%. That makes sense. If you studied, you probably would not have failed. Well, then that one means, or this means that down below I can say the probability that they studied, just kidding, did not study and fail is 0.20 times 0.69. I think that's 138. These two do not add to 1, and that's okay because they're not complements. Studied and failed and not studied and failed are not complements. So it's okay that those two don't add to 1. Okay, next one down here, we can do the same thing. So I'm basically pulling these letters right here. The probability that they studied and passed. This one should be much higher. The probability that they studied and passed. So I'm pulling these two events, S and F complement, and putting an intersection between them, is equal to 80% times 72%, which is 57.6% or 0.576. And then the last one that we can pull or calculate is the probability that they did not study and they passed. Did not study and passed. So you guys find that one just real quick so that I'm not just doing all of them for you. Two, 2, 4? Great. And now, yes. I'll find it. I just don't follow up here. I just missed it. The decimal's still right, though, I'm pretty sure. Thank you. Okay, so then, lastly, if you add all of these together, they equal 1. So if you add all 4 of those intersections up, that represents 100% of the students. Either they studied and failed, didn't study and failed, studied and passed, didn't study and passed. That is the entire sample space. Are you hanging in? Yes, no? Okay, so now we can find a bunch of different probabilities now that we know those. So the first thing that they want us to find is the probability that a student studied. They want us to find P of S, because all they gave us was P of F. Well, I know, and now you know, because I'm going to tell you, that that's going to be the probability that they studied and failed plus the probability they studied and passed. We take the intersections that include S. So that's studied and failed, studied and passed. Those are the only intersections that include S. So that's going to be 0.062 plus 0.576, which gives us 0.638. You're probably going to want to double check that. So if we randomly select a student, the probability that they studied is 64%. 64% of this student or this teacher-student studied. Okay, well then right across from it, they want to know the complement. You could. So you could do 1 minus P of S. And if you hadn't already calculated P of S, then you would do the probability of S complement and F plus the probability of S complement and F complement. So you would do the intersections that have did not study. So I think maybe I want to highlight that. You don't have to if you don't want to. But if they want you to find the P of SC, you pull the intersections with S complement. And over here, if they want you to pull or find the probability of studied, then you add the intersections with studied. Either way, if you do the complement or you add them, we end up at 362. Okay. Ready for the next one? If a student studies, they passed. So P of passed given studied. If a student studies, that's your given, they passed. So this is your given. Well, I reminded you at the beginning of the period what that formula is. It's the intersection of those two things over the probability of S. The intersection over the probability of this guy. We know those now. So this is the probability of FC and S over the probability of S. And the order here does not matter. So if you want to write S and FC, that's fine. This is up in the top part where we calculated FC and S, so 0.576. And the probability of S we calculated right above 0.638. Yeah. It's just a really skinny 0. Okay, what does that give us? 0.903 or 9028, however you prefer to round. Yes. don't know what you're asking me.
Okay, so like, if we're phrasing it out of all of like the people, so say we think about this as like not like a tree diagram and we're just doing it just as straight math, and then we phrase it as like S fusion passed. So like they studied and they passed, and wouldn't that tell us the same number, or am I wrong?
How would you find the probability that they studied and passed without a tree diagram?
I guess like using like it's not in this example specifically, but I'm saying is it the same thing, or am I looking to you and then adding you? Is it like the same thing as switching the two things and adding to you?
No. Oh, so you mean like, would it be, is it related to this formula? Because that's the U. Okay. If you get an example on the next one, ask again. Because I'm happy to answer it. I think I'm just not understanding. Okay, next one. Probability that they fail, given they studied. So, probability they failed, given we know they studied. So we have to pull the probability that they failed and studied over the probability of all the kids that studied. So F and S is 0.062 over 0.638, which I believe is about 10%. The probability that a randomly selected student studied and failed is 10%, which makes sense to me. It should be low if they studied. Okay, two more. If a student doesn't study, they fail. So this is your given this time. So P of fail given did not study. So it's that formula again. Failed and did not study over did not study. So 138 over 362. Just 362. Is that true? Okay. What do you guys get? Thank you. And then the last one, probability that a student passes given they didn't study. So the intersection over the percent that did not study. So this one's 224 over 362. So what does that one equal? 0.619? Okay. So we zoom out. In the beginning of this problem, they gave us 3 probabilities. And with those 3 probabilities, we were able to find 12 other situations. So they gave us the 3 that I have colored in, and all of the other ones are ones that we were able to calculate based off of only 3 probability. Actually, it was 13, not 12. So when you get this on an actual question, they don't ask you to do this many problems. This is just an example of how many you can do if you know these probabilities. Ready for the next example? Was that a yes?
Yes.
Okay.